My name is Keshwani. That's Keshwani. Keshwani. We are here because we want to prepare for GMAT. We have been solving GMAT math problems out of this book here, GMAT Review, the official guide, the 13th edition. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 184. Please turn to it, page number 184, problem number 225. Let's take a look at it, see what it has to say. It says if n is a positive integer, then this quantity here, n times n plus 1 plus n times n plus 2, is which of the following five that applies to it. Let's take a look at the first one. A says that this quantity is even only when n is even. Well, to disprove it, to be able to see if we can actually disprove it, it claims that the quantity is even only when n is even. Let's put in n equal to an odd number for n. Let's put in 3 here. If we put in 3 here, the next one is going to be 4. As soon as you see an even number there, okay, what we have to understand here is that if you have a whole bunch of odd numbers, 3 times 5 times 7 times 37 times 947 times whatever it is, and then at the very end you hear times 4, as soon as you hear the first even number in a chain of product of numbers, it only takes one even number to turn the entire product into an even number. Because a whole bunch of odd numbers, no matter how many times you multiply them, odd numbers times odd numbers times odd numbers times odd number will remain odd. 3 times 5 times 7 times 9 is an odd number, and therefore their product is actually one odd number times an even number. Odd times even is even. And again, this is not something we have to memorize. It only takes 2 seconds to actually do it out. Take an odd number multiplied by even, and you will see that 3 times 2 is 6 is even. So as soon as we first see the even number, the whole product is going to be even, because the next one is going to be 5, but it doesn't matter. But doesn't matter the fact that this is odd and this is odd. The point is that odd times odd is odd, and times even is going to be even. So this claim, the claim that they're making here, that this product is even only when n is even, is false. It's erroneous, because it doesn't matter whether it's n is odd or n is even. If n happens to be even, then the next one is going to be odd, and the one after that is going to be even. But the point is, if it were even to begin with, we wouldn't have to do any of this to start. We wouldn't have to do the rest anyway, because as soon as we see the first even number, as we said, in a chain of the product of a whole bunch of numbers, the whole product is even. So, claim number A is no good. Let's look at second claim. A is no good. Second thing says it's even only when n is odd. It's even only when n is odd. Well, we just saw that when n is even, it's still even. We just saw there that even when n is even, obviously if n is even, it's going to be even. This is silly. It says this product here is claimed that it's even only when n is odd. No. N can be even, and of course it's going to be even because you start out with even. It's a silly question. C says it's odd, this product here is odd whenever n is odd. The product is odd whenever n is odd, which is of course nonsensical, because n is odd right here. N is odd right there. N times n plus 1 times n plus 2. When n is odd, we put in 3 here. 3 times 4 times 5 is even. Whereas this claims that whenever n is odd, this third statement claims that whenever n is odd, the whole product is odd also. No, it's not. Because if you start out with odd number, the next one is going to be even, because they're consecutive. You see, as you can see there, they're consecutive. That's the thing we have to understand. N times n plus 1 times n plus 2, what they have given us, even though they do not say it out loud, what they have given us are 3 consecutive integers. And whenever you have 3 consecutive integers, It doesn't matter what you start out with. If you start out with odd, the very next one is going to be even. If you start out with even to begin with, then the story ends, because if you start out with even, the product is going to be even. But even if you start out with odd, the next one is going to be 1 plus that number, it's going to become even. And the product of any number, as we said, as soon as at least one even number appears, it becomes even. C is wrong. Let's look at D. D says that it is divisible. Let's do it on the top. D and E are getting a little prickly. D says that this quantity here is divisible. N times n plus 1 plus n plus 2 is divisible by 3 only when n is odd, which is absolute nonsense. Because n times n plus 1 plus times n plus 2, it says this quantity is divisible by 3 only when it's odd. All we have to do is plug in a number for n, which is divisible by 3. So if we were to start out with 6, voila, we're done with this. We're done with the whole story, because it doesn't matter what follows here. This product, 6 times 7 times 8, it is divisible by 3. Because obviously 6 can be divided by 2. So this D is nonsense. Let's look at E. E must be the answer, obviously. Let's look at E. E says this quantity is divisible by 4. Let's understand why there is something that has to be true all the time. This quantity right here, n times n plus 1 times n plus 2, is divisible by 4 when n is even. Well, when n is even, I should have done it on the top here, because that's the right answer. We want to understand it. When n is even, what happens? If n happens to be even, it doesn't matter whether you start with 2 or 4 or 6, whatever it is. If n is even, let's say it's 4, then that'll be a silly thing to do, because 4 is 4, then it will be divisible by 4. And let's suppose that n is 2, or let's suppose n is 6. If n is 6, 6 itself is not divisible by 4. But what's going to happen by the time you get here? Times 7 times 8. So if this is not divisible by 4, by the time you get here, this will be divisible by 4. For example, if you start with 2, 2 times 3 times 4, of course that's divisible by 4. What makes it even better is the fact that even if this number happens to be something that is only divisible by 2, if this thing something that happens to be, for example, 10 times 9 times, well, that will be divisible by 4. So if this is an even number, this is an even number, of course if you have two even numbers, the product is going to be divisible by 4. An even number times another even number is divisible by 4. Because if it's an even number, this one is divisible by 2, and if this is even number, this one is divisible by 2. So you can cross out with the 2's. So this one is always going to be true. The answer is E. I was going to take care of the next problem in the one shot, but my phone just rang, so I'm just going to stop here. We'll meet tomorrow again and finish up the last problem on the page, which has to do with the pipe, which is just as well, because it's better if we do that one separately. Okay? I'll see you tomorrow, okay? Bye now.